All right. Good afternoon to everybody who's getting joined in. We went ahead and started just a few seconds early here to make absolutely sure whoever hit that join link got in and could actually see what we have on our screens before we got started here. Usually Zoom takes anywhere between 20 and 30 seconds, and that time it did take about 30 seconds for people to start showing up. So we always want to wait just a second here. Like I told the group in the beginning, we don't want to say the most important thing right before you join in. So, which we wouldn't say the most important thing in the beginning anyway, but you never know, right? All right. So, with that said, today we're going to be talking about oil filter housings. And this is our February webinar. Remember, we have a webinar every month this year where we're going to be talking about different categories. Last month was kits and multi packs. This month is oil filter housing kits. And so we're going to talk about a couple of different things. We're going to start with the opportunities we have with oil filter housings. We're going to briefly touch on what they do, why they fail, a lot of the engineering improvements that we've done here at Standard, some technical tips if you see something out in the shop, and then we're going to close off talking about how Standard stacks up to the competition and what kind of sales support you have at your disposal to continue the conversation about oil filter housing. So when we talk about the opportunity, it's pretty big, right? So one of the reasons we're discussing oil filter housings today, and specifically those for the 3.6 liter Pentastar motors, is because of the overwhelming opportunity that exists. Just in the first 2 months of this year, and we're not even finished with the first 2 months of this year, but we've already seen a nearly 59% increase in units sold versus the same amount of days last year in 2024. That's a huge increase in these oil filter housing kits. And I want, there's quite a few primary drivers of why that's growing and expanding and the opportunity is getting so much more advanced here. And that's because of confidence. It's confidence from the technicians knowing that they're going to get the correct unit and everything they need to get the job done right. And so what do I mean by the correct unit? Why are we seeing this growth the way that it is? Well, we're going to hear a lot more reasons why we're seeing the growth, but one of the reasons is because we have the correct units in the box. And the reason we bring that up is there are currently 6 part numbers that cover from 2011 all the way up to the current 3.6 liter models of Chrysler, Dodge, Jeep, and Rams, right? And so they're there for a reason. There's 6 part numbers for a reason. And while they may look a little bit similar, and in some cases, believe it or not, they will fit like they should, there are differences in the units depending on the application that they're going in. And so things like the oil filter flow rate, different part numbers for the oil temperature sensor and pressure sensor. There's even 2 units that don't even have a temperature sensor. And so, when a technician opens the box and sees that not only is it the full kit, that's one of the primary drivers, it's everything they need, but it's the correct style. That tech now has a lot more confidence installing the oil filter housing as opposed to the fear that they have right now with what can happen when installing a universal design, which is what we see a lot of on the market today. So one of those primary drivers is having the correct unit and the complete unit in the box for those customers. All right, so that's some of the opportunity that we have. So what do they do, right? Well, obviously they filter the oil because they have the oil filter in there, but they don't just filter the oil, they also cool the oil. So there are passages inside of these housings for both coolant and oil. And the coolant is going to help dissipate the heat a little bit more than just say airflow, right? So certain units like this are going to be really dependent on being able to dissipate heat using coolant. And so it's really important that any replacement unit that is used has the same heat dissipating characteristics as the original design because that's what they were designed to do. Using a universal or a different material is going to have different heat dissipating characteristics, and we don't want that. And we got to keep in mind too, the passages are really close together. So any failed sealing point can be a cross contamination issue, and we don't want that either. We're going to talk about that coming up as well. And so, really what they do is they filter the oil, but they also cool the oil down. And we have to understand why they do that. The oil itself is going to help transfer heat from the moving components, the rotating assembly, the valve train, all those metal parts that the oil washes over as we're driving. It's transferring, it's pulling heat away from those parts. So we have to cool that oil down through the oil filter housing so that we can continue those cycles where the oil is pulling heat away from the components and the cooler is pulling heat away from the oil. It's just an ever, evolving cycle as we're driving down the road. So that's what they're doing. That's their goal, not only to filter, but to cool that oil down. And what do we need to cool it down to? Well, the sweet spot, the optimal range for engine oil is between 180 and 220 degrees. And it's a little bit different on transmission, but it's pretty close to the same. But on engine oil, 180 to 220. Now, why is that the sweet spot? Well, that's just what engineers have designed these motors to run on. They designed them to run efficiently at 180 to 220, and especially more efficiently when the oil is at 180 to 220. That just seems to be the sweet spot, right? And so we want to keep the oil within that 180 to 220 degree range so that the oil doesn't break down too quickly. With extreme heat and with extended periods of heat, oil breaks down. And with, oil changes going further and further apart these days, the longer we let the oil break down, the worse it's going to be. Because remember, the oil directly cools the internal engine components. It also acts like a hydraulic fluid as well. So we need the right pressure to actuate and control VVT systems. And here's the big deal. Modern oil has multiple additives that do certain things that break down way too fast when high heat is it's exposed to that for too long. So we don't want high heat. We want that 180 to 220 special, perfect range. And that's what the oil cooler is going to do. It's going to keep it within that 180 to 220. So with those additives, again, these are the things that are going to drive what the oil does and why we got to keep them cool. So what do those additives look like? Well, we're going to start with antioxidants. And these are going to be additives that slow oxidation, which is the primary cause of oil degradation. Oil degrades because of oxidation. So with excessive heat, it's going to accelerate the consumption of those antioxidants, and then we're going to have oil degradation because once depleted, the oxidation occurs rapidly, and that's going to increase the potential for internal wear of the engine. So again, antioxidants inhibit and slow oil oxidation. Next, we have anti-wear additives like ZDDP or zinc dithiophosphate. And this is one of the most common anti-wear additives. And you can think of this as kind of like a smooth sacrificial barrier between the metal surfaces, preventing the friction that causes wear. But again, it will degrade at high temperatures, reducing its effectiveness and preventing that metal-to-metal contact. So we don't want that to wear out. Then we have detergents, and these are going to be designed to prevent corrosion and sludge buildup. So I'm sure we've all seen a valve cover come off, and it's just caked on inside there, and it's because the oil has degraded to a point where the detergents are no longer viable, and it starts building up with sludge and corrosion, because as they degrade, the oil thickens, it becomes sludgy, and it's going to restrict the optimal flow through the oil channels, and that's definitely going to cause damage as well. Or and in worst case, leave excessive carbon deposits, and we definitely don't want that. So we got to get rid of them. We use dispersants to do that. And dispersants are additives that are designed just to keep engines clean. And it does that by suspending the contaminants within the oil. That's why we see oil go in nice and clean. You can see through it. Then when it comes out, you can't even see past it. And it's because it's got all those trapped contaminants, the carbon, all the emissions that it's pulled in. Anything that's gone through the engine, it's pulled those contaminants away, and that's what dispersants do. But also with high heat, they gradually degrade as well. So now we're going to leave those contaminants within the system, and that's definitely what we don't want. And then we have viscosity modifiers, and really all these do is allow for multi-grade oils. But it's more than that. So, if it says it needs a 530 or a 1030 or a 016, the viscosity modifier is what's going to do that. But these are polymers that can break down at really high temperatures. So that's going to cause the oil to thin out, meaning those viscosity ranges it should have, it's no longer going to have, which is going to reduce its performance in maintaining not only viscosity, but across different temperature ranges and to support various systems. Now, one I don't have on here that is important to note as well is anti-foaming agents. And these are just to reduce the oil-air surface tension because we don't want the oil to become foamy. We need pressure. And when we have foamy oil, we don't have pressure. So why do we need pressure? Because we have to have pressure to almost act like a hydraulic fluid to actuate the VVTs. Remember, these solenoids have 3 screens on them. Most of them have 3 screens on them. And it's meant to do one thing. We supply it with oil, we drain the oil out of it, but the pressure that's built up when the PCM commands the VVT system to either advance or retard the system, it has to have the right pressure in the oil so that it can direct that flow through those tiny screens on those solenoids. So if we have dispersants breaking down and we're no longer trapping contaminants, now those contaminants are going to try to go through those screens. If we have detergents breaking down, now we have sludgy oil, and we have sludgy oil trying to go through those screens. And you can see the list goes on and on with those additives. Once those additives break down, we start affecting major systems like VVT, even turbochargers. So that's the reason we have oil coolers, to stay within that 180 to 220 sweet spot so that we don't have horrible effects on systems like VVT when those the detergents and dispersants and all the other additives break down. So how do they fail? Well, on this specific oil filter housing for the 3.6 liter Pentastars, there's actually quite a few reasons they fail, but the myth is that they fail because the housing warps, and that's what causes oil to leak. Well, that's just not true. The high strength heat resistant housing doesn't actually warp itself, but there's quite a few weak points in the OE design. And some of those universal designs that came out on the market over the years, have tried to change the material and, make it aluminum or make it some type of metal or something like that because of the warping myth. But again, it was never warping. And now we're not matching the heat dissipating characteristics of the original design. So by changing the material to fix a problem that was really a myth made no sense. And we're actually creating more heat. What the actual issue is, there's quite a few leaking points on these. Oil can leak at the core plugs where the passages were formed. It can leak from the oil pressure or really even temp sensor if it gets to that point, but that would be a different fluid. And then also the lower seals can fail, causing an oil leak as well. So there's quite a few spots where it can leak, and those are the things we addressed. So the core plugs in the back, there are 3 of them. You can see them all glistening there with the oil all over them. Those core plugs are there because when these are manufactured, the housing itself, those channels have to be left clear for the oil passages and for the coolant passages. So once the molding is done, there's 3 holes left over. What they do is they take the same material of the housing and they plug those holes and they ultrasonically weld them. Well, the problem is it's just a plastic on plastic weld, and any deviation, any small air pocket is enough for oil to find a way out, and oil will find a way out. So how did we fix that? It was pretty simple. We just put O-rings on the core plugs. So now, not only does it have the core plug and it's ultrasonically welded like it's supposed to be, but there is a seal on the inside to keep oil from ever getting to the point where it could reach the outside of the housing. Simple fix, and unfortunately the OE still doesn't do this. So fortunately for us and for you, we do, and this is a solution for your customers. The other one, again, it can leak around the oil pressure sensor. This was literally the exact same issue. The only difference is instead of it being a core plug, it was the brass insert. You have the brass inserts that go into the plastic. They're knurled, so they grab a hold of the plastic and they lock in. But on the OE design, they did not have a seal. They did not have an O-ring on the inside, again, preventing the oil from working its way back. So we fixed that. We put an O-ring on there, and we actually did one for both the oil and the coolant temp sensor because we're already there. We might as well do the correct fix for both while we're in there. And that corrects the oil leaking from that passage. And then on the bottom of this particular housing, there are quite a few seals that are, required and installed whenever the replacement unit's put in. The problem is the OE design seals were weak and they were pretty prone to becoming distorted or crushed, and then of course failing and creating an oil leak. So again, another sealing issue. What we did is we put new distortion resistant seals on it. So these are not going to flex and they're not going to distort and they're not going to crush like the original design. So again, it all comes back down to leaking issues. People thought it was a warp, like the housing was warping. No, it just happened to be that there were multiple points on all corners of these units that were leaking because of sealing issues. And we've corrected those with the standard units. And then one last spot, if you look on the right here, you'll see a little plastic cap with a red O-ring on it. Well, that plastic cap is the only thing that separates the oil from the coolant on this housing. Again, those passages are made when it's manufactured, so there's going to be an opening, so it has to be sealed. Well, they did the same thing on the OE design with this one as they did with the core plugs in the rear, which is they just pushed it together and ultrasonically welded it. Well, we can't have coolant getting in the oil, and this was a common issue, so we took care of that as well. We still have the passage, we still have the plug, but it is now sealed from the inside so that, again, we don't have that cross contamination. So, why do we do all this? Well, because technicians don't like doing jobs twice, 3 times, or 4 times. And this is about a minimum of a 4 hour job on some of the easier applications that you can work on. So, they don't want to do it twice. You have to remove the intake manifold. You need new seals every time you do that. On a lot of these, you have to remove the fuel injectors and the rail. There's just a whole lot of work involved in it. So, remember that whenever we're talking to technicians about the solutions we have with our units, which is you put it in, it stays in. You don't have to worry about leaking anymore because we addressed all the leaking points. But if you do happen to see somebody working on one of these and they're pulling things out, there's nothing wrong with reminding them, hey, cover those intake ports, fill them with a rag or something like that, just in case, because we don't want something falling down in there. Keep in mind, once you take the intake manifold off and you go to remove this unit, you could have coolant and oil spill out a little bit. We don't want that going down into the intake. So, or the actual ports. So that's just one little quick tip if you happen to see it. But if you do happen to talk to a technician who's had a lot of problems with these, they may, tell you that they see that it splits down here at this particular O-ring. This is at the front of the housing below the oil filter neck. And this is the first point of contact. When you go to install one of these units, this is the first seal that gets pushed into place. And we have to think about this kind of like an oil filter, an old spin-on oil filter. We always did a little bit of lubrication around the O-ring or the seal on the oil filter before we squeezed it up there. Well, we need to do the same thing with this seal. If we have a technician that's got one that's tearing or ripping or crushing a lot, let's find out, are they greasing it first? Are they putting a little bit of lubrication on it before trying to insert it? Once you get this one guided in, everything kind of floats into place. But guiding this one in is very common that it gets torn. Another quick tip, if you've got someone who's got customers coming back saying, hey, I know you just put a new filter housing and all that was done on my car, but I still have a leak. Let's make sure if we see that the valley is still filled with oil, we remind them, hey, that valley underneath where that oil filter housing sits, it can hold over a quart of oil. And some of the vehicles, it can hold up to, close to 2. So if we don't clean that out, once we get done, before we even repair it, before we put the new unit in, if we don't clean that all out, it can still be left in the valley. You may have done the job, and then a week later, the customer comes back and says, hey, I still have oil spots in my driveway. Well, it's not because the oil filter housing failed. It's because there was still oil left in that valley, and that can cause a comeback pretty quick. And then another big one, and this is something we've talked about for a couple years now. On these oil filter housing caps, when you get our unit in, it's already torqued to the right specification, which is 18 foot-pounds. But you really don't have to torque this too hard, right? 18 foot-pounds is hardly anything by hand. And we've seen where technicians will crank down on these and really get them on there snug. It's not really when they're putting the cap on that it can crack the housing. It's when they're trying to take it off where somebody over tightened it. So it's important to let these technicians know when you see them working on these, hey, just tighten that down like you would an oil filter. You don't have to, give it just all kinds of strength. You don't have to go Thor on it. Just tighten it down, make sure it's not going to leak, and then you're good to go. Because otherwise, it can create a problem for the technician later on down the road. But fortunately, our units are made with a higher strength material, so you shouldn't have to worry about that anyway. But on some of the units that they're taking off, they've definitely seen this. So with that, the last thing I'm going to bring up is don't forget related parts with these oil filter housing kits. Anytime they're replacing one, they're going to have engine oil. They're going to have coolant. If they're using a filter housing that is not ours, which means it doesn't include the filter, they're going to need a filter as well. But hopefully, this is going to be enough information for you to get out there and get the word spread that these are the units they need to be using. And then also recommended, while you're in there, you got a couple things took apart, maybe some spark plugs and some coolant hoses. So there's some great add-on sale opportunities there as well, along with the opportunities we already have, which is just increased growth, exponentially at this point and going even further. So with that, I'm going to pass it over to Mr. Stephen Tony now, who's going to talk about some other aspects of these housings that are going to give you some great talking points when you're out there having conversations with technicians. So, Tony, show's yours, sir. Take it away.
All right, thank you, Corey. So, as Corey has already mentioned, the myth with these oil filter housings is that housing does warp. And because of that, you may see some other housings out in the field that use an aluminum design. And what we found is, using a metal or aluminum housing can retain much more heat than intended. We kind of look at it like we look at a frying pan on a heated stove. You have a metal frying pan and you have a metal handle. Well, that handle is going to retain that heat. You go down to pick up that frying pan with the handle and you're going to end up burning your hand. So that's where standards housing has been designed with this Zytel technology, which is a trademark of DuPont. What it is a high temp synthetic thermoplastic material, and it has good electrical and flammability properties and performs excellent at high temperatures. So using this Zytel technology in our housings, it helps cool the oil as it goes through the housing because, after all, these housings are oil coolers. Next slide. So Standard also offers 6 different oil filter housing kits depending on the applications for your vehicle applications. You'll see a lot of housings out in the market that are universal. Specifically, a lot of those aluminum housings are universal. Now, the issue we've come across with that is they don't use the intended oil filter, which is application specific, like Standard does. So anytime you receive, or anytime a standard oil filter housing kit is installed, it includes that application specific filter. Some of those universal housings, they have to use a certain filter that isn't application specific, and no matter which vehicle you use, you have to use a specific filter that may not be applicated to that actual vehicle. And that can just cause some confusion and make it difficult for the technician when they're replacing these. Another great thing about Standard's oil filter housing kits, they come completely assembled. We offer the oil pressure sensors, the oil temperature sensors, heat exchangers, lower mounting gaskets, the correct oil filter and cap, as I just mentioned, the manifold gaskets, and the mounting hardware. So those sensors, those are already installed, and with those, the oil filter cap, as Corey mentioned earlier, it's already torqued to the correct OE specs. What we've seen is as it can be tightened a little too tight sometimes, and as people go to unscrew the cap, it ends up cracking. So having it torqued to the correct specs just prevents any future damage as well. And then just onto our engineering and testing for these. So just to continually make improvements on OE designs, standard oil filter housing kits and their installed components do undergo extensive testing, so they can be installed with confidence. These housings are pressure tested for leaks, and the oil pressure sensors and oil temperature sensors are tested for accuracy. And then also, while we test all of the parts and components that go into this kit, any new applications that we want to add an oil filter housing to, we test it on the vehicle to make sure it's a proper fit. And here just shows our complete coverage compared to our competitors. As you can see, Standard covers 11% more than our closest competitor. And we offer over 200 total applications amongst all 6 of our oil filter housing kits. And then this is a great slide. So this just shows the key differences between what Standard offers versus what our competitors show. So as you can see, one of the biggest things with these oil filter housing kits is the gaskets need to be replaced anytime you're installing new oil filter housing. A lot of our competitors don't include those gaskets, and then when they do offer the gaskets, or if they offer the sensors along with it, those sensors aren't installed. As mentioned by Corey, and I think I've mentioned it previously too, our oil filter housing kits are completely assembled, ready to be installed right out of the box. We found that, replacing sensors from previous oil filter housing kits, it can lead to damaging those sensors. So just having them installed again, just gets the job done right the first time. And then the last thing I'll share with you all before I pass it off to Aaron is just the overall category as a whole for oil filter housings. It is a fast-growing category right now in the aftermarket, and these newer style housing design has replaced the spin-on filters, and that's resulting in improved filtration and lessening the environmental impact of disposable metal oil filters. So we do recommend that distributors and parts stores carve out a little additional space to meet increased demands of the technicians. And then this is just highlighting 4 of our top movers outside of those Pentastar oil filter housing kits. All right, and with that, I'll pass it off to Aaron.
Yeah, Stephen, thank you very much. And Corey, great job. There was a lot of value there explaining the why is so important to keep oil at or close to its designed operating temperature so it doesn't break down. So what you see on screen is a piece that we created to support a much larger industry initiative. I'm not sure if you've heard of this or familiar with it, but Check the Part is a group of like-minded manufacturers that are supported by MEMA and the Auto Care Association with a pretty robust campaign to help reduce fraudulent warranties and give parts professionals tools and ammunition to really better do your job and make sure that any part that is accepted as a return is a valid warranty. So there is a website, checkthepart.com, that has been created. We encourage you to check that out, learn more about what you can do to reduce fraudulent warranties. And this is a piece that we had to create about 2 years ago to address head on the number of low cost, low quality units that were getting returned in our boxes. And what was happening was that the original unit was failing. People were buying a very inexpensive unit. They would put it on a vehicle, it would fail very quickly. And then to correct that, they would install one of our units. They didn't want to pay full price for ours. So they put the lower cost, low quality unit back that they had just bought a few months prior back in the standard box and tried to bounce it back. So we started to see more and more of these as we were going through our returns in the warehouses. So it was critical that we address this one head on. So this is a simple guide that shows how you can open the box, check the part, and you can always determine if it's one of our oil filter housings. This is a part that we manufacture ourselves, so it will always have a stamp on the side of the unit. It'll look like that. This is the part number is always referenced as the first 3 numbers. Those digits should align with the part number. And then from there, we have manufacturing date codes. So very handy piece. This is available on our website too, if you want to download it. And actually, you can also download it from checkthepart.com as well as support materials from other manufacturers. In addition to this, we have a lot of support materials to actually help you sell the parts. So we have a lot of printed materials that are available through our sales team and also to download from our website. We have a 6-page product brochure. We create new item spotlights. We recently created one on this category that featured the top 9 up and coming numbers that our category insights team would suggest that part stores add because we're starting to see very strong sales out in these applications across the board. Then we have a really simple two-sided flyer that we call the What's in Your Box flyer. On YouTube, we have over 700 videos, and we have our own dedicated oil filter housing kit playlist. This has 6 videos, including a very detailed installation video. And then lastly, if you really want to dive in deeper and learn more about these, we have about a 15-page digital product guide that you can download from standardbrand.com. So for that, you go to Standard Brand, go to Digital Resources, and then you can just type in oil filter housing. It'll pop up right there along with the other materials. But that thing called Digital Product Portfolio, you can download that and learn. It's kind of the next level of information beyond a brochure or even beyond a training session like this. Lastly, we can wrap this up. There's a lot out there. We're not going to spend a ton of time telling you what's in everybody else's box, but we're proud about what's in ours. There's multiple design improvements to prevent leaks. The other big thing is it's put together. It's a completely assembled kit. It's the drop-in solution. If you're in a store where you do some walk-in business with do-it-yourselfers, this product is very, very popular with those folks. And even more and more professional technicians are choosing a product like this. And, as Corey touched on, they're also oil coolers. And ours is designed so you're not cooling the oil and then heating it right back up, dumping it through a big metal passageway before it goes back into the engine. So, you'll also see with ours industry leading coverage. And, to sum it up, the 2 things that we can say about our program, the 2 things that you could say when somebody's at the counter and says, well, why should I choose the standard one? Well, it's complete and correct. And it's complete, meaning we have complete coverage. But more important than that, it's complete because it is already put together and nobody has to do anything. And it's correct because we've done the hard work from the engineering standpoint. And that's where it was determined that we did need to have 6 part numbers to correctly cover these applications. And then we've done it on the cataloging side. So what you see in your store system in the electronic cataloging is correct, and you can trust that, and that can be installed on a vehicle and keep the vehicle operating exactly as designed. So that's what we had for you this afternoon. We'll open it up and see if there's any questions.
No, we don't have any questions, Aaron. I think you summed it up perfectly there, complete and correct. And I think that's the right way to go about having the discussions on these oil filter housing kits. So, yeah, I'm not going to steal any of your thunder on that one. That was good. So, with that, I'll just say thank you to everybody that's here. I know, again, it's a lot to get away from the counter for a little while or get out of the shops for a little while and spend some time with us, but we do appreciate it. And thank you to our panelists that were here. And we will see you next month when we talk about AC components, kits, and getting ready for that AC selling season. So have a great rest of your day. And again, thanks for being here. We'll see you soon.
Thanks, everyone.